All right. Let's get started here. First and foremost, welcome to Autodesk Virtual Academy. I'm Nigel Umbayak, one of the customer success managers here at KETIV. And today I'm joined by Eric Paul. How's it going, Eric?
Good morning, going good, Nigel.
Awesome, awesome. Great to hear. So Eric is one of the engineers on our team who specializes in a lot of the programming and automation of the products and processes. So definitely a good person to have on the webinar today. And this is something we've talked about doing for quite some time now. We're going to be going over some iLogic, specifically going over operators and expressions within iLogic to kind of build I would say, foundation to be able to start automating your processes and your designs. I think as I was talking to Eric about this, it's kind of fundamental to be able to look at some of this stuff, to be able to optimize that code and to be able to generate some of it in the first place. So definitely want to go over this and make sure that everyone has a solid foundation when they're trying to automate their stuff. And we'll go through this. So expect to be here for the next, what is it, Eric, about half hour, 40 minutes or so.
Yeah, about a half hour.
And yeah, feel free to ask any questions that you may have. Go ahead and type those into your respective chat/questions panels. And without further ado, Eric, do you have anything else to add before we get started?
No. So I mean, this is going to be really important to add these pieces of information to your toolkit. Kind of tough to know how you can accomplish things if you don't have the full toolkit in front of you to know what's even possible. So this is going to help really expand your foundation, really get you some more options on what you can do.
Yep.
All right.
Cool. With that, I'll let you go ahead and get started, Eric, and we'll see you on the other side.
Sounds good. So operators and expressions. Now, iLogic, the little window that we can bring up when we add a rule within Inventor, that is V. This is a common language created by Microsoft, and there is extensive documentation on what VB.NET can and can't do. There is about 99% of what the base VB.NET options and functions, expressions, operators, 99% of that is brought over into the iLogic environment. You'll find a couple of things here and there. There were one or two that I was hoping I could show, but wasn't able to, that was dealing with things that don't exist, that didn't make it over. But for the vast majority, whatever you find, as documentation for VB.NET, you'll be able to use with iLogic. So today we're going to take a look at a couple of different types of operators, arithmetic operators, comparison, concatenation, adding things, different parts together. We're going to do some logical operators, assignment, making variables, other variables or values, as well as some shortcut operators that can help you with loops, cut down a little bit on your typing there. And then we'll kind of tie it all together and see how we can make some expressions with all of these new options in your toolkit. So let me go ahead and get Inventor open here, and we'll get started. So the first thing we're going to take a look at is some of the arithmetic options you have. Go ahead and edit this. We can take a look. This is basically going to be, if you're familiar with adding stuff to a graphing calculator, it's going to be the same thing there, right? The only difference is some of the more unusual options like square root. And there's actually, if you look over here to the side under math, you can see quite a few little functions and helpful things, stuff like absolute value, pi, sine, cosine, tangent, all that good stuff is in here. Just go ahead and, so for instance, if you wanted to get the sine of an angle, right, you just double click that. You can put in whatever you want, or you can just type it out. But do take a look at this math section. So here we've got an example of using square root. And again, just like with your standard math equations, you can use parentheses, and do make sure that you're using them extensively so that you can have it work exactly like you want. There's a handful of times where you expect it to work this way or the other. I'm always a proponent of using excessive amounts of parentheses just so you can make sure you've got it exactly the way you want. So I'll show you a quick example here. As you see, this is the first version is 10 times 3, which is 30 plus 4 gives you 34. And then, of course, in this version where we have the parentheses around the 3 plus 4, that makes it 7. So 10 times 7, 70. So, just really make sure you're taking a look at that and keeping a lookout so you get all that sorted out. Bring it up real quick again, just to show you, so you're familiar with the plus, the minus, multiplication. Again, like graphing calculator, it's going to be the asterisk. Division is going to be a /, and then if you want to, take something to the power of something, it's the caret there. So that's all pretty standard. Just want to make sure that you've seen it so that, down the road, you're like, oh, what was I supposed to do for that? It's right there. And again, look up vb.net if you're ever looking for, oh yeah, what was that? You can find it there. All right, so that's the basic ones, right? The only one I will change here is, for instance, you can assign a negative value to this. So the minus sign isn't just for subtraction, it's also for turning something into a negative value. So let me just delete this real quick, and we'll say, value 2 is value 3 is actually going to be the negative of value 2. And let's just do a quick message box, and we'll say value 2. And we're going to create a carriage return. That's what the VBCR is. And then we'll do value 3. And we'll see 34, and then the negative of 34, which should be, negative 34. Run that real quick. And there you can see, it sets that. So it's not just subtraction, it's also setting negative. All right, so what you might not be, too familiar with is there's a different type of division you can do, and this makes it really interesting for programming. It, helps shortcut things quite a bit, and it's what's known as integer division. And integer division, this returns the quotient. So that's the integer that represents, the number of times the divisor can divide into the dividend without consideration for the remainder, right? So it basically just chops off the remainder, and it just gives you that whole number. So this can be, really helpful when you need a whole number for something. So for instance, in patterns, if you need to know, hey, this needs to be this many bolt holes, doing this integer division is super helpful. So integer division is going to be, so standard division is a /, integer division is going to be a \. So let me go ahead and run this real quick, and we'll see the difference there. And so you can see, standard division, you're going to have 7 divided by 3, you get your value. Integer division just completely chops off everything else, and the value that it returns is an integer type of object. So again, really helpful when patterns and things that are just looking for straight integers there. The next one we're going to go over is a modulus. This is almost the opposite of integer division, where all it's returning is the remainder. So it divides the two numbers, and just the integer, the remainder is given to you. Take a quick look at what this looks like. So we're going to use the keyword mod to do this. And you can see I've got it listed out here. So again, using the 7 and 3 again, 7 mod 3, let's see what that value looks like. And that gives us 1. That's a little bit unexpected. Let me see if I messed that up. Oh yeah, no, that makes sense. So that's the remainder, the whole, the remainder is 1 after we do that. So it goes in twice, right? And then the remainder is 1. And so we've got remainder of 1. Now, one of the ways that it's super helpful to use, you know, real quick one is this even or is this odd? So let me nuke this real quick. So let's say, you know, we're looking to find out, is our height even or odd, right? So I've got a user parameter that's already set up here called height. So we're going to say, you know, if height mod 2 is 0, then we know it's even. That is, we divided height by 2, and there is no remainder. So we know it's an even number. And so we can do a message box here. Height is even. And if, let's save it and run it. And we know our height is even because we checked here. And yeah, height is 6, so that makes sense. So if I change this to 7, right, and we run it, nothing happens because it's an even number. So, you know, in your code, maybe that's not exactly what you want. Maybe you need to understand all the different types. You want it to express if it's even or odd, right? So we're going to use an else statement here. So if the height is even, it's going to take this path. And then we want to know if it's anything other than even, we want it to say height is odd. Go ahead and save that. And now when we run it, we can see height is odd. Change this back to 8. And run it again. And we're back to even. All right. One of the other ways that it's handy to use is when you want to check in on something occasionally. So maybe you've got a really large loop, right? Maybe you're looking through an Excel spreadsheet, and you've got thousands and thousands of cells in there that you're crawling through, and maybe you've got you only want to update every once in a while, right? So you could create a loop where, hey, only every 10, every 100 times we're going through this loop, I want to know, give me an update. So here I've got a quick little example, right? So we're going to loop through from 1 to 100, and anytime the value is divisible by 10, that is, we divide it, that the remainder is 0, then we're going to bring up a message box and we're going to say what the value is, right? So we'd expect this to show up on 10, 20, 30, et cetera, et cetera. We'll just run this real quick. There we go, 10, 20, 30, 40, and that's what we want. So that can be helpful for, maybe updating a progress bar or giving some information to the user. Maybe you want them to be able to kick out of the loop, have it go every 1,000 and say, hey, do you still want to keep going? Something like that. All right, so that is the arithmetic stuff we're going to do for right now. Now we're going to move on a little bit to combining some of these into expressions. Go ahead and open up this. So as you can see in the back, right now we've got this red extrusion, and what we're going to do is we're going to start playing around with different expressions here, and we're going to have the color change depending on if we're getting our correct values. So right now I have this set to if the height is larger than the width, I want things to be red. If not, I want it to be blue. Okay, so let me actually turn on the rule. Unsuppress that, we'll run it. And because height is 8, smaller than the width of 12, we've got blue. Once this gets larger, it turns to red. All right, so we can go this back and forth. You kind of see this changing. So as soon as this runs, as soon as we change this value, this script, which is now active, runs, and it changes the color immediately. So this is a very basic one, right? So this was just using greater than. We can also use less than, greater than or equal to, less than or equal to, right? Those are some of our options for comparison here. In combination with that, we're going to be able to use the keywords or and and. And so and, that keyword, what it means is all expressions must be true for it to continue down the path. So let's try an and here. So let's say if height is greater than width and height is greater than depth, then we want it to be red. Otherwise, let's keep it to blue. So save it and run it. And so right now, our height is greater than both the width and the depth. However, if we make the depth bigger, it goes back to blue. See, it's still larger than width, but because both of them aren't true, then it's going to the other path. Once I get that smaller, now it's active again. So the difference then between the or and the and, if instead of and I put or just means only one of these has to be true. So either height needs to be larger than width or height needs to be larger than depth. So we'll go ahead and run this. And when I make this depth larger than height again, it's still red because height is still larger than width because only one of them needs to express as true. Larger doesn't matter. Once I get smaller, they both need to be. There we go. See, once height is smaller than both, then none of them are true, and so it's blue. And there's a little shortcutting that we can do here. Sometimes your expressions are going to be, let's call it expensive. It takes a lot of time to compare one thing and another. Maybe the way you've got it set up, it needs to go ask inventor some questions that takes a few seconds, and you have like maybe, I don't know, 5, 10 different things that it could be, and you want to make this a little bit faster. There are 2 options here. It's called for or, it's called or else. And what this does is it changes the way it reads these comparisons. In this version, it first compares this, then it compares this. Whereas with or, it'll compare everything and then at the end decide if it's valid. If you do or else, it'll go one by one. And so it can be a lot faster because the first time it finds a true, then it knows, oh, okay, I don't even care about the rest of it. I'm just going to keep going on into this path. The version for and, standard is and. The shortcut version is and also. So that can be helpful. Speed up your comparisons, your loops, make things a little bit faster. Let's see here. Okay, so there is another somewhat bizarre option here. And let me see if I've got it in this one or the next. I'll leave that the way it is. Okay, so let me show you in here. And it's what's known as XOR. So this is going to be kind of like OR, where it's saying, hey, if any of these options are true, then we have a valid path. The difference between OR and XOR is that with XOR, only one of the paths can be true. Okay, so that makes it a little bit different. So I've got the code already copied over here. And, so we're going to be where we were here, if height is larger than width or height is larger than depth, we're going to go red. But here's this different one using XOR, right? And we're using a combination of different types of comparisons here. So let's say it's very similar to this top one, where height is larger than width, or height is larger than depth, or height equals 10, right? But remember, with these XORs, only one of these can be true. So this will only happen if height is smaller than or equal to width, height is smaller than or equal to depth, and height equals 10, right? Or it could be some other combination where only one of these is actually set to valid. So let me show you a little bit what that would look like here, and we'll get it to green, right? And so in this example, to get it to green, I'm going to make the height smaller than both width and depth, but the height will be 10. So we've got one single item that is true. So we're going to set the height to 10, and then the width and the depth is larger, right? So once I get two of them that are true, it goes back to red. But once I get only that one true, we get green, right? And so it's a little bit of a tricky one, but that's the point of this thing, is trying to just show you all the various bizarre things in your toolbox to when you're setting up your logic, that you can really have all your options available to you. All right. So that kind of leads us into the next one here, which is dealing with negatives, right? So we've dealt mostly with positives, when things are true, when things are this way. We're going to start looking a little bit into what happens if we're looking for the opposite of something. And we're also going to look a little bit, at equivalence here. So there's two different ways of looking at equivalence. There is object to object and value to value. And so the two different options there are using the keyword is, and that compares the references, the objects. The other one, which you're more familiar with, is equal sign. And that's just going to compare the values. And so they're very similar, but there are some slight differences that you may run into. So feel free to use equal sign extensively. Just know that down the road you may need to look into this a little bit more as things get more complicated. So the opposite of is and equal are going to be is not, and in this case, this is the unequal. One of the reasons I'm bringing this up is that unequal is not always going to be an option. So sometimes you're going to have to use this not keyword or is not. That's a little bit more rare, but you are definitely going to run into times we're going to say, hey, when this is not equal to that, and then you're going to run into an error because there's not actually that set up for it. So here's a couple of different examples we've got. The first one we're looking at, this can be used for error checking. So for instance, if you don't want to multiply, if you don't want to ruin height because depth was 0, and this is going to be this cascading, everything becomes 0 because things are multiplied on each other. We've got some error checking here where we're saying, if as long as depth is not 0, then height can be depth times 2, right? And so another way that we can express that, this is the exact same thing, if depth is not equal to 0, because the data type of depth does have this not equal to option. Let's take a look here at some of the other things we can do. For instance, strings. Strings can often, have nothing in them. They can just be blank, like we're seeing here. And sometimes it's a problem. You want to make sure that as you're reading things in, you're not passing non-existent values. And so this is another way that you can use not and nothing. This is a keyword here that is a equivalence. So it means whatever for string means there's nothing there. Since it, for a string, it can't be 0 because it's a different type of data type. You're going to use this is not nothing. So as long as something is in this color value, then we'll make the color set there. So let's take a quick look at what it would mean one way or the other. Let me turn this on. And right now, I can set this to blue or red or yellow, right? And if I set it to nothing, oops, sorry, oh, it's saying that's a problem. So, we want to use the error catching here. And that's why I've got this is, let me uncomment this. We're going to use a special item called trim. And this is something you can do on a string data type. So it takes out all the white space. So no matter if it's in the front or in the back, this will take out any white space from text. And so in this case, it's going to leave us with nothing, right? And so we're going to have that set up here. And now we can deal with this space, right? So we have green, that works. We put in a space. That still doesn't crash anything, right? It doesn't set it, but now we don't crash. We don't get that error. So that's some of the ways we can use not. We can use the negatives. Look for something that isn't there, because that's really tough. Usually it's tough to find things that aren't there. So putting that all together, I'm going to give you a quick little example of how we can use that. Turn this off. And one of the main examples that we can do for that is, let's say we want to have a pattern of bolt holes, up here that are based on the height of it, so that we don't have to set it, right? We just have a rule that calculates that for us. And so in this case, let me go ahead and turn it on. Let's press, okay, so now, right now we've only got 2 of these holes. Let's press this. And what we want to do is, this is actually 2 inches up, and every 2 inches we want a bolt hole, right? And so what I've got here is I'm saying, okay, let's take the height, let's subtract this first 2 inches, and because we don't just want the inner, we want the outer count, we're going to not subtract the top. So it's actually looking at like the outer count instead of the inner count. And we're going to say, if working height is not equal to or less than 0, right? Because we could have a height of, say, 1, and then we try to work this here. We can run into some errors, and we don't want that at all, right? We're trying to set up no errors. So we're saying as long as we have a valid positive number, then we're going to say our bolt count is the working height, and this is integer division 2, right? So this is going to give us an integer number always, and so this, again, really nice way to use that. Let me save it and run it. And there we can see, because I have this pattern set up to have the number of elements be this, this parameter here, bolt count, it's going to automatically update whenever this changes. So if we change this to 15, no problem, it's still there. 16, there we go. Right, so this is a cool way that we can have things dynamically update. All right, next thing, combining values. So oftentimes, you can have multiple variables, and you want to jam them together. Not necessarily always just addition and subtraction. Sometimes you want to combine, right? Concatenation. So we're going to just go over this real quick here. Let's see. Okay. So, you might be tempted to use this plus because, hey, it works, right? And so you've got this string 1, string 2, and just like math, you're like, hey, I want to jam these together, message 1 plus message 2. Let's see what we get, right? So let me go ahead and run it. And yes, we get hello and world. The issue comes when we start dealing with math and strings, right? We'll start getting some very bizarre things happening. So let me copy over some more items here. So let's say, I've got some string elements, I have some value elements that are numbers, and I want to jam them all together into one final string at the end. I want to say, hello world 3, 7. When I go ahead and try to run this, it says, hey, I'm trying, but this isn't working out. I don't understand what to do. I've got numbers, I've got strings. I don't understand why this is happening. The reason is you should really be using the ampersand. Whenever you're dealing with strings and concatenation, that's, adding the things together, you actually want to use the ampersand symbol. And that'll let it know that, hey, we're just combining these. We don't actually want to try to add them. So in this case, just changing these two, we'll now get, let's see if you can guess, is it going to be hello world 3 and 7, or is it going to be hello world 10? All right, we'll run it. And it's actually hello world 10, because you're using that plus, it's doing math. So again, if you're ever dealing with strings and you want to be putting things together, you want to use that ampersand. And if we use that here, now we can see not 10 anymore, it's 3 and 7. All right. Shortcuts. Let's go to, you know what? I do want to hit on one more thing here, just really quickly. One of the other versions of setting up selective pathways is not just the if-then, but also the select case. And I believe they've got options in here as well. Yeah. So we've got select case. And what this will do is this is super helpful when you've got like a list of different things. So in this case, maybe all sorts of different stuff should happen based off of the value of height. And with select case, this is way easier to write than if you're doing, than putting it out into an if-then statement. because you can do things like using this to keyword. So we can say, hey, if the number is anywhere between 1 and 5, take this pathway. You can also have multiple things happen by using the comma. So we can say, if it's 1 to 5, go this way. If it's 6, 7, or 8 exclusively, we know that's that. Or if it's less than or equal to 0, that's going to be a bad extrusion for us. And if it's something else, we can do case else and catch that as well. So let me just run this real quick. Let me turn it on. And so now we've got, a large number. If I take this down to 7, it found it there. If I take it down to 4, which was between 1 and 5, right, we're catching that. So you can kind of see how we are, going to these different pathways. All right, and the very last thing, if you're dealing with loops a lot or adding things together, there is a shortcut that you can do. Instead of having to say, for each of these bolt placements, let's say you need to know where to set the next one. Maybe you're doing this automatically. You're placing them one by one. Instead of having to say, let me just copy this, bolt Y placement equals bolt Y placement plus 10. This is a shortcutted version of this. So it can be kind of handy. It can also, depending, it can read a little bit better. So that was one of the things, and that works for both subtractive, multiplicative, division, integer division. That is the wrong thing I meant to do. That, so you can do a log. And importantly, you can use this with the ampersand. So let's see here. I've got an example here. So this is one of the cool ways we can use it by using the ampersand. So we're combining what we had before, and we're going to add on to that string. We're going to say, here's the new number that we're at right now. So if I run this real quick, we were able to combine the initial part of the string, and then we kept concatenating these numbers onto it, and then we just expressed it at the very end. All right, I think I made it under the time limit, Nigel.
You're right there, dude. 30. So yeah, right there. Cool. Should we just hop straight to questions, Eric?
Absolutely.
Cool. Let's go ahead and take a look at some of these. If you want to go ahead and type another question in, go ahead and type those in, and we'll go ahead and address those. Let's see. Can you only use the integer division in the iLogic browser, or not the browser, the iLogic window, or can you use that in like the parameters window as well?
Ooh, that's a good question. Let's find out right now. I really like that question. So let's say width is going to be height \2. Nope, no integer division in here. Doesn't like it. We can do that, but we can't do that.
Cool.
So there you go.
And done.
All right, any others in there?
Yeah, there's a couple more. One just came in. Is there any way to display debug messages besides the message box?
That's a great question. There is finally, and in fact, I think someone else on the team is actually putting together an AVA for this already. There is now, what was it? I know it's in 2020. It might be in 2019, a way to connect up Visual Basic, the Visual Studio to iLogic and be able to do live debugging through that. So there is now a pathway for that. If we want to grab his name there, Nigel, remind, we can send them the information on that. There's a
Yep.
write-up.
Yeah, I know Matt's working on that AVA, so we'll grab that too.
Cool.
All right, now last question that we have that's written up right here. What if the values are equal in the XOR?
Right. So for the XOR to work, I think it's in, do I have it in this one? No, it's in the other. These, so, you know, this is one of the ones where we use the equivalence, the equal sign. The way that this works is for this path to be valid, we can only have a single item that evaluates to true. And so if multiple evaluate to true, then that's not going to work. If they all evaluate to false, that's not going to work. It can only be one single item that evaluates to true for it to be valid.
To go to the next line, essentially.
Yep.
So again, thanks, Eric, for being here today, or I guess not here, being electronically here today. And we'll see you for the next AVA. So join us next week. Brian Monkelpunsek, one of our colleagues, is going to be going over some surfacing in Inventor. So stay tuned for that, and we'll see you on the flip side. Thanks, everybody.
Bye, everyone.
Talk to you all later.